The talk I'm going to give tonight is called The Language of Birds. I like to say that all around us all the time, the birds are always telling us who they are and what they're doing. And the problem is that a lot of us don't speak bird. But we can actually remedy that. We can learn what the birds are telling us, and we can kind of listen in on their messages. So here's an example. That bird just told you that it's a red-winged blackbird. It just told you that it was a male, and it just told you a few other things, which we'll get to in a minute. That bird also just told you it was a red-winged blackbird. It told you it was a female, and it told you a few other things, which we'll get to in a minute. We can actually learn the individual sounds of different species and figure out what they're saying to one another. So, for example, that's a bird called a cliff swallow. You may be familiar with cliff swallows. They like to nest in colonies under bridges or in culverts. And if you walk up under the bridge where the cliff swallows are nesting, they will all fly out over your head and circle around you, and they will all make this sound. Because that little zoo sound is the word in cliff swallow language that means danger. That means they're kind of upset that you're walking up to their nests under their bridge. But cliff swallows have other words in their language as well, like this one. That is a call that cliff swallows only give on cool, cloudy days. Because on cool, cloudy days, it becomes difficult to be a cliff swallow. Cliff swallows feed on swarms of flying insects, and when it's rainy and misty and cold, the insects don't like to fly. So the cliff swallows get hungry. What they do on those cold, rainy, cloudy days is they spread out from their colony in different directions, hoping that one of them will get lucky and actually find a swarm of insects that is flying despite the weather. If they get lucky and find that swarm of flying insects, they make this sound. And that immediately recruits all the other members of the colony within earshot to come as quickly as possible and take advantage of that swarm of flying insects while it is still on the wing. Now, it's possible that other species of swallows have food finding calls like the cliff swallow, but if they do, we don't know about it. In fact, the only reason we know what that word means in cliff swallow language is because there was one researcher who kept going back to study the same colony of cliff swallows in Nebraska every summer for 24 years. And somewhere around year 14 of that study, they discovered this call and did a kind of ingenious series of experiments to demonstrate what it actually means. The vast majority of birds in the world have not been that well studied. And so that's actually one of the things I love the most about studying bird sounds. Whenever you are studying bird sounds, you are standing right at the edge of human knowledge. It is way easier for anybody in this Zoom call right now to go out in their backyard and record a bird sound that's never been recorded before than it is for any of you to take your cameras anywhere in the world and photograph a bird that's never been photographed before. That's what I think is so amazing about bird sounds, is that we have so much to learn still about what the birds are saying to one another, including about common birds that are right in our own backyards. And we'll talk a little bit more later tonight about how you can actually contribute to learning more. Tonight, we're going to focus on what birds are saying to one another, and we're going to focus on certain species that actually have been well studied so that we do have a pretty good idea of what their language is saying. And that's going to bring us back to this pair of red-winged blackbirds that we already met. In fact, we're going to come back to this pair of red-winged blackbirds more than once tonight, in part because it's one of those few birds that's been really well studied in terms of its vocal communication, and also in part because red-winged blackbird is hands down the most vocally interesting species in North America. You may be familiar with the male song of red-winged blackbird. You heard it a minute ago, a couple of slides back. The male sings "Konkari," sitting up on a cattail in a marsh all summer long. The males sing that song. But what you may not recognize is that the male and the female red-winged blackbird often duet. They duet with one another, and you probably have heard it hundreds of times if you've been anywhere near a marsh where red-winged blackbirds are nesting, but you may not have recognized that you were listening to a duet. In part because the male song and the female song of red-winged blackbirds sound nothing alike. The male sings "Konkari." The female says something more like "Chir." So the two sounds, the two songs don't sound anything alike. The second reason you might not recognize the duet is because when they duet, they don't sing at the exact same time. The male starts singing, and then half a second later, the female starts singing. So he starts singing, they overlap for a little bit in the middle, and then she finishes it out. And because they sound so different, and because they're not singing at exactly the same time, it's hard to recognize as a duet if you don't know what you're listening for. And the third reason you might not recognize it as a duet is because when they're duetting, they might not be sitting right next to each other, like I've placed these two birds on this slide. They might be 5 feet apart, they might be 50 feet apart. The male might be up on a cattail stalk where you can see him. The female might be hidden down somewhere in the reeds near the nest. But if you hear this duet, you can reliably say that you are listening to a mated pair. It sounds like this. That's the male singing and the female responding halfway through his song. And that is those two birds saying, "I love you" to one another. That is a pair bonding exercise between that mated pair of birds. Male red-winged blackbirds will mate with multiple females, and they will defend their female against other males. And female red-winged blackbirds will defend their male against other females. And so when they're saying "I love you" to one another, and they're not just doing that, they're also sending a message to all the other red-winged blackbirds in the marsh. They're also saying "I'm taken," or more specifically, they're saying "my mate is taken." There's no more room for another female or another male on this particular territory. Now, that is a duet that you've heard a lot of times. And one of the interesting things is that related birds do the exact same thing. So meadowlarks do the exact same thing. The female has a rattle call. She starts it halfway through her mate's song. Those two birds could be 100 meters apart on the prairie, and yet they are actually telling you and telling all the other meadowlarks in earshot that they are a mated pair. Brown-headed cowbirds do the exact same thing. The female has a rattle call. She starts it halfway through her mate's song. That's them declaring that they're a mated pair. Knowing this is really useful if you're doing like breeding bird survey work or breeding bird atlas work, because you can actually identify which birds are mated and which birds are not if you understand this aspect of their singing behavior. Now, male red-winged blackbirds actually have two different kinds of songs. The more common song is the one we just heard, the "Konkari," that you hear hundreds of times when you're near any marsh in the summer. They also have a much less common song that we call the flight song, because it's almost always given when the bird is in flight. And we don't have a perfect idea of exactly what the flight song means, but here's our best guess. The male red-winged blackbird gives a flight song sometimes when he's flying away from his territory. If you're going to hear a flight song, it's usually because the male is flying away from his territory. So the best guess is that it's the male signaling to the female that he's leaving the territory for a little bit and she's going to have to hold down the fort while he's gone. But that may or may not be exactly what the flight song means, because they don't give it every time they fly away from their territory. And once in a while, they'll give it when they're flying back to their territory. So it's not entirely clear what the male's flight song actually means. As you were listening to that flight song, it may have sounded to you just like a string of call notes put together, which is basically what it is. A bunch of different call notes with usually with a couple of those seer, seer notes in the middle. But every individual male red-winged blackbird has his own specific flight song that is unique to him. And so if you know all the individuals in the marsh, you can actually tell which one is which by their flight songs. Now, female red-winged blackbirds also have two different kinds of songs. One is the one we already heard, the I love you / I'm taken song. But they also have a more aggressive version of the song that they give whenever they are defending their territory against another female red-winged blackbird. And it sounds like this. You can hear that that sounds harsher, rougher. It's more aggressive. The interesting thing is that female red-winged blackbirds can actually mix and match the notes from those two kinds of songs to send a range of intermediate messages. So they can actually express the full emotional range from I love you to get out of my territory just by kind of mixing different parts of those two songs. In bird language, sometimes one sound can have many meanings. And that's not too strange when you consider that human language works the exact same way. So in English, we have a bunch of words that sound the same, but they mean different things. And whenever we hear one of those words, we figure out which word, which meaning is intended from context. Birds do the exact same thing. So for example, here's a little ruby-crowned kinglet. In the summertime, when he is nesting up in the pine forest, up in the conifer forest, he's got this long, complex three-part song that he's going to sing. He's got a couple of other kinds of sounds that he makes during the summer. But in the wintertime, when he comes down to the coast or down to the southern United States, all winter long, these ruby-crowned kinglets basically just have one call that they make. And it's just a little chit, chit, chit kind of call. Sounds like this. So that little chit, chit, chit call has to serve multiple functions for the ruby-crowned kinglets all winter long. It's the way that they warn of danger, but it's also just the way that they keep a flock together by saying, I'm over here. And it's also the way that they recruit other small birds to drive away owls. If they find a pygmy owl, for example, they'll use this exact same call to bring all the other little birds in and try to drive the owl away. So how do the other birds know whether the ruby-crowned kinglet's chit-chit is saying danger or come drive this owl away or here I am? The answer is context. Just the same way that we pay attention to context so that we can tell which meaning is intended by those words that sound the same, birds are going to do the exact same thing. So the other birds around this kinglet are going to pay attention to how agitated it looks, how agitated it's acting, whether his little red crest is erect or whether it's hidden, whether he's orienting in a particular direction, seeming to like be pointed towards a predator, or whether he's just kind of nonchalantly foraging, how rapid and agitated the sounds. All of those things together are going to help the other birds figure out which of those possible meanings is intended. And again, that doesn't seem strange to us because that's exactly the way that human language works as well. However, if one sound can have many meanings in bird language, it's also true that sometimes one meaning can have many sounds. And the example I'm going to use for this is the bird species that, as far as we know, has the largest vocabulary of any bird species in the world. It's not a mockingbird, but it is a relative of the mockingbird. It's not a bird that you're going to have in Vancouver, but it is a bird that can be found in eastern Canada, southeastern Canada, and the eastern United States. It is the brown thrasher. And the song of a brown thrasher, if you've never heard it, the bird sings a phrase that's about 1 second long, and then it goes silent for about a second, and then it sings a different phrase for about a second, and then it goes silent for about a second, and then it sings a different phrase for about a second, and so on and so forth. I'm going to play you a little snippet of brown thrasher song, and I want you to try to listen and see if the bird ever repeats itself. You just listened to 40 seconds of brown thrasher song, and none of those 1 second phrases were repeated during that 40 seconds. And so researchers wanted to know, how many phrases does one brown thrasher know? So a researcher named Donald Kreutzma and one of his grad students, they went out on the campus of the University of Massachusetts, and they recorded one singing brown thrasher for 113 straight minutes. So just shy of 2 hours of bird song from one individual bird. And then they took that recording back into the lab and they tried to estimate how many phrases or words that individual bird could sing. When they were all done with their estimates, their best guess was that that individual bird could sing somewhere between 2,000 and 2,500 different song phrases. Just to put that in perspective, your vocabulary as an adult speaker of English is probably on the order of 25,000 words. So here's a bird that has a vocabulary maybe 10% the size of yours, and its brain is the size of your fingernail. That's astonishing, but it's possible that brown thrashers are saving some brain space when they're remembering all those words, because as far as we can tell, every single one of those words in brown thrasher language means the exact same thing. Every single one of those song phrases means, I'm a brown thrasher and I'm looking for someone to share my territory with. Which immediately raises the question, why do you need 2,500 ways to say that? And the answer is, we have no idea. Science does not have an answer to this question of why the brown thrasher needs 2,500 different ways to say that. Just to put that in perspective, mockingbirds, which are famous for their large vocabulary, they have a vocabulary somewhere on the order of 250 phrases. So the brown thrasher's vocabulary is 10 times larger than a mockingbird's. If you ask scientists how that vocabulary got so large, the typical answer you will hear is sexual selection. which is also known as female choice. The basic idea being that at some point in the evolutionary history of the brown thrasher, females developed a preference for males who did not repeat themselves. And so the idea is the females choose the males with larger vocabularies over time, and over time, the vocabularies of the chicks get larger and larger, and that's how this happens. Here's the problem with that theory as I see it. In order for that to work, the female brown thrasher has to choose consistently the male with 2,500 song phrases over the neighboring male with only 2,200 song phrases, which means that she has to listen to everything that comes out of both of their mouths for hours, if not days, and remember it all so that she knows when one of them starts to repeat. And we're pretty sure that the females are smart enough not to put in that much effort. So if that's not how they are judging their mates, then it must be something else. And the question of how the vocabulary got so large and what keeps it so large is unanswered still. Because presumably it takes a lot of energy, time, and brain power to learn and remember and deliver all those different songs. And it's probably like beyond the practical capacity of the females to actually keep all of those things in mind. So here's a bird that's really, really common. This is a backyard bird for people all across Eastern North America. And yet we don't have the answer to this fundamental question about its singing behavior. This, again, is what I love about bird sounds. Here's a super common bird that people could record in their backyards and help crack this mystery over time. And yet we don't know so much about this bird's song. So I just told you that sometimes in bird language, one sound can have many meanings, and sometimes one meaning can have many sounds, and sometimes it's complicated. And for this, we're going to come back to our old friends, the red-winged blackbirds. Only this time, we're going to talk not about songs, but about calls. So the red-winged blackbird, whenever he's not singing or doing something else like foraging, he's probably sitting up on a cattail in the marsh giving call notes. Just giving call notes over and over again every couple of seconds. That's what they do. Most of those call notes from red-winged blackbirds sound more or less like chuck. And then a couple of them will usually sound something more like seer. And each individual male red-winged blackbird knows between 12 and 20 of these different kinds of what we call alert calls. So 12 to 20 different chuck or seer type calls that he has to choose from. He'll just sit up on his cattail and give these calls over and over again. Here's an example of what these calls sound like. That's 10 different alert calls from a male red-winged blackbird. That could be half of that individual male's alert call vocabulary. He could know up to 20 of these different calls, most of them more or less like chuck, some of them like seer. What this male will do is he'll sit up on his cattail all day long and he will pick one of the calls that he knows and he will just give it over and over again. And all the other males sitting up on all the other cattails in the same marsh, they all know the exact same 12 to 20 alert calls. They all share a vocabulary. And they will all sit up on their cattails and they will all give the same call as each other all around the marsh. Next time you go to a red-winged blackbird marsh, listen for this. Listen for all the males kind of giving the same call over and over again, echoing each other all around the marsh. If you, interestingly, like I said, all the males in this marsh share a vocabulary of 12 to 20 of the same alert calls. But if you drive 50 kilometers down the road to a different marsh, you will find that all the males in that marsh also agree on 12 to 20 alert calls, but it's a different set than the ones in the first marsh. So geographically across the continent, the sets of calls change, but within one marsh, they tend to be agreed upon by all the males who live there. Researchers noticed that whenever danger would appear, whenever a hawk would fly over or a human would walk into the marsh, the calls would change. And that suggests a reason why male red-winged blackbirds have 12 to 20 different versions of this call. Maybe the different calls carried different meanings. For example, maybe different calls corresponded to different types of predator. Or maybe they corresponded to different directions that the danger could be coming from. Or maybe they correspond to different levels of danger. So some are lower and some are higher alarm. Researchers wanted to get to the bottom of this, and so they got themselves a stuffed Cooper's hawk, and they put it on a stick. And then they got themselves a bed sheet and a really long string. So they could go out into the marsh with this Cooper's hawk on a stick, and they could stick the stick into the marsh right in front of the favorite singing perch of a male red-winged blackbird, and they could put the bed sheet over the hawk, and then they could back up a long ways with that string. And they could wait for the male red-winged blackbird to get used to this bed sheet and go back and sit on his perch and start singing or calling again. And then the researchers could whip that bed sheet off, and from the perspective of the male red-winged blackbird, it would be like a Cooper's hawk just showed up right away in front of the perch. And the researchers recorded the calls that the male red-winged blackbirds were giving before and after the hawk appeared. So for example, let's say before the hawk appears, all the male red-winged blackbirds have chosen this call. They're all echoing each other all around the marsh. And then the researchers whip that bed sheet off. The hawk appears. And the call changes. The first male to see the hawk switches to this seer call. And as soon as that first male to see the hawk switches to the seer call, all the other males in the marsh immediately follow suit. They immediately switch to the seer call as well. So the researchers thought, well, maybe that seer call means Cooper's hawk. So they ran the experiment again. Let's say that before the hawk shows up, all the males are giving this call, echoing each other. The bed sheet comes off, and the males switch to that call. Try it again. Say before the hawk shows up, the males are giving this call. And they switch to that one. As they did this experiment over and over again, what the researchers eventually realized is that it doesn't matter which call the male red-winged blackbirds switch to when the Cooper's hawk shows up. What matters is that they switch calls. In other words, any call repeated over and over again in red-winged blackbird language means all clear. And any switch from one call to another means danger. When I learned about this, it absolutely blew my mind, because this is so far away from the way that human language works. I just had no concept that language could work this way. That's one of my favorite things about bird language. I've been using this word bird language all night, but there is not one bird language. There are over 10,000 bird languages, because every species of bird on Earth has come to its own solution to the problem of how to communicate using sound. And some of them have come up with solutions that look nothing like our solutions for how to communicate using sound. I love that nature is here telling us how different, how diverse life on this planet can be. and reminding us that we don't have everything always figured out. One of my favorite things about bird language. That brings me to the book I wrote about bird language. The books, the Peterson Field Guides to Bird Sounds, one for Eastern, one for Western North America. I intended these books to be a dictionary for the language of the birds so that you could actually kind of go into the book and figure out what each species is saying. I said earlier tonight that not very many birds have actually been really well studied in terms of their vocal communication. So the phrase you will see over and over again in the book is more study needed. I think that phrase appears multiple times on almost every page of this book. But if we do know things about what the birds are saying, I tried to put them into the books to the best of my ability. Another thing I tried to do in these books is I tried to use a standardized vocabulary for sounds. We already have a standard vocabulary to describe what birds look like. So much so that if I saw a bird and I wrote down in detail what it looked like and then handed you just the description that I wrote down, you would probably be able to figure out what bird I saw just from the description, if I was detailed enough. There's absolutely no reason we can't do the same thing for sounds. It's just that we haven't agreed on the words we're going to use for the different parts of a sound. We've all agreed on the words we use visually for birds. We've agreed on the names of the colors, for example. We've agreed on the names of the parts of a bird. There's a little diagram at the start of every bird book that teaches you what all the parts of a bird are named. We agree on the names of the patterns. We agree on the difference, for example, between a spot and a stripe. There's no reason we can't do the same thing for sounds. So what I tried to do in my book was develop a standardized vocabulary for sounds that uses words that we already use to describe bird sounds, but defines them precisely and uses them consistently. So that if you actually learn this vocabulary and then describe a sound, other people will be able to figure out what sound it was. If you can do that, you can compare similar sounding species. And you can actually look up a sound you don't know, just like you could look up a word in the dictionary as long as you can spell it, even if you don't know what it means. So for example, the inside back cover of the book, the last 2 pages of the book, ask the question, what did you hear? Over on that leftmost column, those are all the single notes. So if you heard a single note from a bird, you kind of match it to those descriptions there, and then it sends you back to this index at the back where there's a list of similar sounding birds. Here's all the birds that sound like this, and then it'll list those birds and send you the page numbers to get to their species accounts earlier in the book. That second column there on the left-hand page is if you heard the same note repeated over and over again, as in a series or a trill, and then over on the right are all the more complicated song patterns. So this is one way to look up a sound that you don't know. There's another way to look up sounds that you don't know, and that's that you can use a spectrogram app on your phone. The one that you're looking at here is called Song Sleuth. Unfortunately, it has been discontinued. It was the best app I knew of to create spectrograms from bird sounds. But we do have Merlin that we can use now. And Merlin will actually not only take the spectrogram and make the recording for you, but it'll also attempt to identify the bird for you. And it's decently good at that. It does make some mistakes. It doesn't know every single sound of every single bird, but for common things and loud things, it's usually pretty accurate. And it's a really wonderful way to get into identifying bird sounds. And the beautiful thing too is that if you can make that spectrogram on your phone, you can get a picture of the sound while the bird is actually singing. You can just hold up your phone to the bird and the bird will just sign its name right on your phone as it's singing. And if you know the shape of the bird sound, you can actually recognize it, recognize the species that way. If you don't recognize it, you can actually take that picture and go to the Peterson Field Guide to Bird Sounds and match the picture to the picture, match your spectrogram on your phone to the spectrogram in the book. And matching pictures to pictures is what field guides have always been about. So it takes audio identification and turns it into a visual process. And visuals have often worked a lot better for a lot of us than trying to remember sounds has. I should mention that there's a website that accompanies my book. It's called petersonbirdsounds.com. And it's free to use. No purchase of the book is necessary. On that website, you can listen to over 7,500 bird sounds from all around North America. It is, if I say so myself, the best curated and most complete set of bird sounds ever compiled for the continent. If you go there, it'll redirect you to this Cornell page, and you can enter the name of a species down below and say you enter northern mockingbird. It'll show you all the northern mockingbird sounds, and it'll tell you which exact sound you're going to hear from each of those recordings. And then if you click on one, it'll show you the spectrogram of the sound as it plays. It'll scroll that spectrogram as the song plays, which is a really wonderful way to start to match those pictures of the sound, the spectrograms, to the actual sounds, is just by listening to birds and watching those shapes scroll past. So that brings us to the end of my prepared remarks today. I would like to thank you for listening and thank you for having me. And at this point, I'm going to open it up to questions from the audience, and we can stay as long as you want. I will talk about bird sounds all night if you let me.
That's great, Nathan. There is a question in the chat from Denis. I don't know if you see it. I can read it out to you as well.
Let me see. I don't have the chat up at the moment. Here we go. All right. How much vocabulary overlap between different brown thrasher individuals? That is an easy question to answer. We have no idea. No one has ever studied that. When I told you that that the researchers went out and recorded a single brown thrasher singing for 113 straight minutes, that is the only brown thrasher that's been seriously studied, the only individual. So there's an N of 1 in that study. And no one has ever tried to compare one brown thrasher's song to another, as far as I'm aware. If there's been a study like that, it's very recent and I have missed it. But I don't think anybody has ever looked into that. That type of question is hard to answer for a bird with 2,000 different songs. It's really hard to answer. So we have good answers to that question for birds like song sparrow and red-winged blackbird, but which have much smaller vocabularies. But it's really challenging to try to figure that out for a brown thrasher. And I see Maureen has a wonderful follow-up question. Is it possible the brown thrasher is improvising rather than using a vocabulary? Yes, this is a possibility. We know that some birds do improvise like this. So for example, well, there's kind of different things we could mean when we say improvise. Let me back up a step. It is possible that the brown thrasher is improvising for at least some of its song phrases. Some of those song phrases might be given and then never, ever repeated. It might be more like a jazz musician. We don't know. What we do know is that at least some of those song phrases are remembered and repeated hours or days apart. You will hear the exact same song phrase come back again if you listen through recordings of that same individual. So at least part of that vocabulary is memorized and then redeployed. It may be that the whole thing is. That seems to be the standard way that birds do it. Most birds memorize their vocabulary within the first year of their life. And then whatever they memorize in that first year, they're stuck with. They can't learn new sounds later in life, most birds. A few birds can learn new sounds later in life, like mockingbirds, parrots, but most birds are stuck with whatever they learned in their first year. We do know that sedge wrens improvise their song types, which means they don't learn their songs from their parents. They just make up a new song that they're going to sing, and it just happens to follow this basic sedge wren pattern. We know that robins learn some of their song types, some of their song phrases from their parents, and then make up new ones for a certain percentage of their vocabulary. So that's improvisation in the bird world. However, it's a different kind of thing than a jazz musician, because when the robin or the sedge wren is making up a new song in its first year of life, once it makes up that song and memorizes it, it's going to stick with that improvised song for the rest of its life. It's going to keep singing it. It's the only one that ever sings that song, the only individual that sings exactly that song, but it's going to sing exactly that song over and over again its whole life. I see a question from John. For birds in urban settings, do their sounds vary due to noises in urban settings? Yes, we have some good studies on this, and it's been shown that birds do have to adapt their songs if there's lots of car noise, airplane noise, that kind of thing. So birds in London were shown to, like in urban London, were shown to have to sing louder and at higher pitch than the same species just outside of London in order to be heard over all the cars. And there was another study done here in Colorado that showed that some birds had to modify their songs in Southwest Colorado in the desert area once oil and gas rigs were put in that made constant chugging sounds out in the pinyon juniper area. Some birds just abandoned the area instead of trying to compete with the noise, and other species just sang louder or higher in pitch to try to get over it. But yes, we do know that noise pollution affects birds, and they have to either move, which some species do because they can't tolerate the noise, and other species adapt their songs accordingly. These are great questions. What other questions does anybody have?
Yeah, I'll just unmute and ask you. I've noticed that when I was in the balcony working away with the plants, one time I played music and the hummingbird actually showed up more often than when I did not play music. So I was wondering if they're, oh, I guess they communicate with each other with calls and songs, whether they're attracted to the music. That's my hypothesis.
That's very interesting. I have not heard that before, and I'm not sure that anybody has studied that in terms of human music. Birds can hear basically the same range of frequencies that we can. So they're not hearing stuff that we don't hear. They're not making high-pitched sounds like bats that we can't hear. There's a couple species actually that make really low-pitched sounds, lower than most species can hear. But for the most part, birds are hearing what we can hear. So human music would sound pretty much to them the way it sounds to us, except that one thing we know about bird hearing is that they have faster time discrimination than we do. What that means is they can hear things that happen. They can hear sounds that are way shorter than what we can hear. They can distinguish faster sets of notes, for example, than we can distinguish. And so if you're going to play human music for them, they're probably hearing kind of like a slowed down version of it, if that makes sense. They're hearing it in more detail than we do. And so I don't know how they would react to it, because it probably sounds pretty different from most bird sounds, but it's possible that they might have a reaction to it, either a positive or a negative one, depending on the song or depending on the bird. it's probably something that they would definitely be tuned into and notice.
Great, thank you. John has a follow-up question in the chat.
In the chat, he asks, do any bird predators mimic sounds to fool their prey? Fascinating question. We don't have any evidence yet that there are any predatory birds that do this. The one situation in which this has been hypothesized, you may have noticed that Steller's jays, blue jays, gray jays, they like to imitate raptors. They like to imitate hawks. And so if you hear a hawk, sometimes you have to ask yourself, is that a real hawk or is that a jay imitating a hawk? Why do jays imitate hawks? Jays don't imitate hardly any other types of birds. Well, gray jays like to imitate shorebirds for some reason, but other than that, gray jays, Steller jays, blue jays, they love to imitate primarily raptors, all kinds of raptors. And we don't exactly know why. One of the theories there is that the jays are trying to scare other birds around them into startling, maybe revealing the location of a nest so that the jay can predate the nest, eat the eggs. I've heard that theory. I've also heard the theory that jays are imitating hawks when there's an actual hawk around, so as to give away the presence of the silent hawk and alert all the other birds to the presence of the hawk. In my experience, the blue jays that live in my neighborhood, I hear them imitating hawks on a fairly regular basis, but it's almost never in one of those two situations. It's almost never when there's an actual hawk around that I can find. And it's almost never during the breeding season when birds would be revealing locations of nests. So it's usually solo jays in the fall is when I hear them imitating hawks the most. So I don't know that anyone has truly solved this mystery of why jays imitate hawks. And it does not, I don't think there's any good evidence that it is actually imitating a predator in order to draw in prey or try to intimidate smaller birds.
I have a question about ravens.
Oh, yeah.
I live on Bowen Island and we have very active ravens, but I just came back from Vancouver Island and the raven sounds are very different. The calls are different. The bell-like sounds aren't where I was hearing them, like quite different. So what's the scoop on ravens?
The scoop on ravens, as you may have heard, is that ravens are pretty much the smartest birds in the world, ravens and crows. Parrots might be up there pretty close, but ravens and crows are really hard to beat. If you have not read all the research on how smart crows and ravens are, go read it. It is terrifying how smart crows and ravens are. They know individual humans. They can recognize your face and they will remember you. If you ever persecute a crow or a raven, they will remember you for basically the rest of their lives. For the rest of your life, you will be harassed by crows and ravens every time you go outside. If you're ever mean to a crow or a raven, they can actually tell each other about you, and then the ravens and crows that have only heard of you will hate you. It's just amazing what they can actually do. Crows and ravens live in flocks. They're social birds. And they all look and sound, the individuals look and sound the same to us. We can't tell individual crows and ravens apart, but every crow and raven in the flock knows every other one in the flock by both sight and sound. They can tell each other apart. They know exactly who's who in that flock. The same way that we recognize people by their faces and by their voices, crows and ravens know each other individually. And there's a pecking order. There's a hierarchy, a social hierarchy. There's an alpha male and an alpha female in every flock. There's a second-ranked male and a second-ranked female and third-ranked male. And it goes all the way down. Everybody's got a rank with X number of ravens above and X number of ravens below. And they all are acutely aware of where they stand. And they're always trying to climb up the ladder. It's very middle school. And that type of bird that lives in flocks and has complex social interactions, those are the birds that develop high intelligence. And we know that they can tell each other things like, that human over there is really mean, remember that one. And yet it all sounds to our ear like some version of caw. Like we can't, there's like lots of detail apparently going on in those caw notes and in all the other sounds that the birds make, that the ravens and the crows make. There's lots of information being traded, and it's not the kind of things that we can hear with our human ears. Like we can't distinguish the difference between the words in crow and raven language. And yet clearly there's a lot of information in there. There are a lot of people doing studies on this, and nobody has cracked this code. We're not even close to cracking this code on crows and ravens. There's so much going on there. It's going to be years before we understand how they are communicating vocally. They're some of the most fascinating and complex sounds in the bird world, particularly because they don't sound that complex. But yes, there's differences that are regional. There's differences that are individual. One flock and another flock, they have different, jargon and slang. How it all works, we don't actually know, but we know there's a lot going on there.
Since you're talking about crows, can you hear that? The rattle. Every time I hear it, I just stare at this. It's very funny. Anyone knows what it means?
I think I heard that. I think I heard that you called it the rattle call of a crow or a raven, like a kind of call.
Yes.
So that is a call. We don't exactly know what it means, but there is a cool thing I can tell you about that call. In jays and in crows and ravens, they all have this rattly kind of call. And when you hear the rattle, it's almost certainly coming from a female. And it's usually the dominant female, the number one ranked female in the flock that usually gives those rattle calls. Exactly what they mean, we don't know, but it's primarily females and usually the highest ranked female in the flock that's giving those calls, which is cool.
Thank you.
I will draw your attention back to the text, Nathan. Michelle had a question, and then Joanna has another question for you.
And I also see a question from Rosemary that came straight to me. I'll go in order. So Michelle's question, can starlings learn new songs throughout their lives? We had a starling in our neighborhood who imitated a bald eagle, by the way. I've heard starlings imitate all sorts of stuff. I've heard starlings imitate almost every bird. Starlings can do killdeer better than the original. And one time I was in a place where there was a flagpole the rope kept dinging against the flagpole, going ding, ding in the wind. And then right next to it, there was a starling making that exact same song, like ding, ding. So I don't know if starlings can learn new songs throughout their lives. Starlings have been fairly well studied, mostly in Europe. Their songs have been fairly well studied because it's a bird that's common and it's a bird that can be kept easily in captivity. And so at least captive starlings, they have studied. If they can learn new songs, raising them in captivity is a great way to figure that out. I don't actually know. I would have to go back and dig into the literature to see if anyone has shown that starlings can learn new songs. But I am unaware that anyone has shown that because it's unusual in the bird world for birds to be able to learn new songs throughout their lives. We know that mockingbirds can do it. We know that parrots can do it. There's not a whole lot more birds than that, but starlings would be a good candidate. I don't know for sure. The next question is from Rosemary. Why do gray jays mimic shorebirds when they are in two different areas not near each other? Rosemary, that is a fine question. I have no idea why gray jays like to imitate shorebirds, but they do. First of all, I will say that many shorebirds actually do breed up in the boreal forest where gray jays also breed. So you will hear them imitating shorebirds that they are likely to hear, like yellowlegs and solitary sandpipers that actually nest nearby, and that they probably are hearing regularly, spotted sandpipers, those kinds of things. As to why they key in on those songs and raptor songs and not any of the other songs, I haven't the foggiest, but I've heard them imitate shorebirds. I've heard plenty of recordings of them imitate different species of shorebirds. It seems to be a thing with that species, for some reason that we don't know. Here's a great question from Joanna. I was wondering if you can talk a little bit about the popular belief that birdsong is an exclusively male trait, and if there are any new insights into female bird song. So, if you ever want to have me back for another talk, I actually have a whole other presentation on the songs of female birds. It's worth an entire night. But just the brief version is that bird song is absolutely not an exclusively male trait. The reason we think that is a combination of baked in misogyny during the Victorian era and the fact that the first people to actually do a lot of ornithological work lived at high latitude, as you do, as I do, lived in a temperate region where most of the birds were migratory. So in the tropics, where the birds are usually resident on their territories 365 days a year, it is standard for both the male and the female to sing in the tropics. Both the male and the female are living on the same territory. They share the duties of defending that territory. It's just standard for male and female birds to sing in the tropics. Migratory birds, what often happens is that the male and the female end up dividing up the duties. So the males over time end up migrating earlier in the spring so that they can set up territories. There's a risk involved with migrating earlier. The earlier you get there, the better territory you can stake out, but you're also running the risk of either starving to death or dying from the weather if you get there too soon. So it's this balancing act for the males, how soon they can get there. And so they usually arrive first, and they're the ones then singing to try to establish and defend a territory. And then the females follow later, and then they have their pick of males, and each male already has a territory. And so the females don't sing because they don't have to sing, because the territories have already been established by the time the female birds come back. But if you take female birds into the laboratory and you inject them with testosterone, you will find that they sing just like males, which means that they have not lost the ability to sing, merely the urge. And it does happen that you will hear female birds sing. Some species you hear that all the time, like black-headed grosbeaks, females sing all the time. Every species of oriole, females sing all the time. Whereas other birds, it's rarer to hear females sing, or like I showed you with the red-winged blackbird, sometimes the females sound different than the males, and so we just don't call it a song, even though it's a song. You know, it's performing the same function as male song. So again, I could talk about that all night. I'll try to stop it right there. Let's see. I see a comment from Maureen that she's heard grackles imitating sounds like doors opening and construction sounds. That's highly likely. I mean, actual grackle song sounds kind of like a squeaky door hinge anyway. But yes, birds will imitate things like that. another question, at what age would the starling have learned the flagpole song? If very young, would several siblings learn the same sounds? So it's highly likely that most birds are learning their songs. Most birds are born in the summer. And then the following spring is when they have to start defending their first spring territory. So in that first 9 months of their life is when most birds are learning their songs. If you've ever listened in the fall, you can hear sometimes birds giving little warbly, weird songs, kind of soft songs that are kind of rambling. The birds are often hidden in the bushes. It doesn't quite, a lot of times you'll be like, I don't know exactly what that is that's singing. It's not very loud. It's very complicated. It doesn't sound like anything that I really recognize. Those are young birds practicing, and they haven't got their species song down yet. And a lot of those birds will go all the way down to their wintering grounds, and they will keep practicing, and they will practice more on their northbound migration. And it's not until their first spring that they kind of like finally lock in their learning of their new sounds. So in most of the species that we've studied, where different individuals have different songs, different versions of the species song, the young birds do not learn their song types that they're going to sing for the rest of their lives from their parents. It's more likely that they're going to learn their song types that they're going to sing for the rest of their lives from their neighbors on their first spring territory, wherever they have dispersed to. So if they've moved 5 miles from the nest and set up a new territory, then it's likely the neighboring birds at their new spot that they're actually going to learn from and sound like for the rest of their lives. So it's likely that those birds learned their sounds in the first 9 months, but the siblings from a nest might end up sounding different because they might have dispersed in different directions from the nest. Aha, and another good question from Maureen. Is there any evidence of conflict if blackbirds, for example, need to move to a new pond? Is it hard to learn the new 12 to 20 sounds, the new 12 to 20 alert calls? That's a fine question that I have had for many years, and I don't think anybody has ever studied this. We know that those 12 to 20 alert calls are learned. We know that they tend to be the same in one marsh, but we also know that, and we know that they tend to be different between different marshes. But we also know that red-winged blackbirds don't nest in the exact same spot every single year. Individuals don't necessarily nest in the exact same spot every year. You know, if you've ever been driving out on a country road and there's just water in the ditch this year that wasn't there last year, and there's cattails growing here this year that weren't there last year, there's red-winged blackbirds in those cattails, guaranteed. They move around because they live in marshes, and marshes are by their nature not there every year. If there's a drought, the birds move somewhere else, you know? So they must be, and they're migratory too, and they're spending all winter long in huge flocks somewhere else with others of their kind, a lot more than the ones that they nest near. So there has to be opportunities for these birds to mix. There has to be opportunities for these birds to be maybe relearning new calls as they move from one place to another. But that has not been shown. Again, this gets into stuff that's harder to study, because in order to answer a question like that, you have to follow into individual birds from marsh to marsh over multiple years and record them all along the way. So that takes tracking technology and time and money and resources that not too many researchers have. So it's a tough study to do. But I have this exact same question about a whole bunch of other birds, like American tree sparrows and redpolls. The American tree sparrows that come down in the wintertime from the Arctic, they move around in flocks, and they give these little tee-wit calls, and all the members of one flock will sound exactly the same. They have the same exact tee-wit call, but then you move to a different flock and they're all singing a different tee-wit call. But again, this is in the wintertime. So these birds are going to disperse in the summer to different, areas of the breeding grounds. Are they going to come back to the same flock next winter? Or are they going to join a new flock, and are they all going to agree on a new call? We don't know. Red polls and other finches match call types with one another. So every red poll flock in the wintertime, all the red polls sound the same as each other. And then they're going to sound different from the next red poll flock that comes in. Are they always together, the same ones in the winter? Or, are they using those calls to find each other like crossbills do? Or are they just matching calls so that they can fit in with their new flock? It's been shown that finches do that in captivity, so they could be doing it in the wild. We just don't know. Oh gosh, Joanna asks, is there any new innovative technologies that have changed the way we do citizen science? Technologies related to bird vocalizations, I mean. Well, yes. I mean, the biggest one is Merlin and automatic identification of sounds. That has absolutely revolutionized birding in so many ways. I have friends who were never interested in birds, it's not that they weren't interested in birds, it was that they were never birders. And now they've downloaded Merlin and they're texting me all the time about all the cool birds that they have in their backyards, because now they have somebody to tell them what they're hearing and they're super excited about it. And that's huge. That's really expanded. It's lowered the bar and expanded access to birding for tons and tons of people, which is super exciting. And there's so many other cool technologies. I have a whole other talk that's about the way technology is changing the way we bird now, including automatic ID and Modus towers for tracking individual birds on migration. And because the transmitters are getting smaller and smaller and smaller, so now we can put them on new species and track them. Really, really neat stuff going on in the technology world. And I see John asking, am I engaging in any citizen science projects? I'm an obsessive e-birder. So eBird is one of the largest citizen science projects in history, and I eBird daily. I upload checklists from all the birds I'm seeing, which allows us to track populations, migrations, changes over time in bird population. So that is absolutely, if you use eBird, that is absolutely citizen science. I also use iNaturalist and a bunch of these other apps that are all citizen science. Upload sounds to Xenocanto, all of that is citizen science. And then I'm also, as was said in my bio at the start, I'm a board member of the Bird Conservancy of the Rockies, which is a wonderful nonprofit organization that is dedicated to conserving grassland birds primarily, our most threatened habitat and our most threatened suite of birds in North America is the grassland species. And so we're very heavily investing in Modus towers in the Great Plains to try to establish migratory connectivity so that we know for birds like Baird sparrow and Sprague's pipit and burrowing owl and grasshopper sparrow, these highly, highly threatened birds whose 90% of whose territory is on private land. We're trying to figure out how to figure out where those which birds breeding here are wintering where and migrating through where, and what areas do we need to conserve in order to keep these hot populations healthy. I think I've caught up to all the questions at the moment.
Yeah, I think the questions have all been addressed. I think this is such a fascinating talk, Nathan. I have hosted a lot of bird talks, and this is a very entertaining talk that I don't think you meant it to be funny, but it's just so interesting to put it in a human perspective in terms of the communication with each other and maybe with us too. So yeah, this is a really wonderful talk. I'll hand it over to Joanna to do the closing remarks.
In respect for Nathan's time, it is time to conclude tonight's very interesting presentation. On behalf of Nature Vancouver, we would like to thank you for tonight's presentation. Thank you for the introduction into the fascinating world of bird vocalizations. I hope that we get the opportunity to hear you speak again in the near future. With this, I conclude tonight's meeting and thank everyone for their participation. Have a wonderful evening.
Thank you.
Yeah,
everybody.
so much.
Yes, thank you. I really hope that you can come back and give us your other talks that you mentioned, Nathan.
I would be happy to.
That'll be